Everyone picturing Earth from another planet pictures the blue marble, and that's a fair picture to have. It's the only one we've ever really been shown. Then Curiosity photographed Earth from Mars, 400 times further away than the Moon, and we came out as one point of light beside a fainter one. And Mars is the good seat. It only gets harder from there, until one planet needs a camera to hide before it can look at us. The reason the view falls apart has nothing to do with size. It's about where Earth is allowed to sit in somebody else's sky. From every planet beyond us, Earth orbits closer to the Sun than they do, which means we can never be off on our own in the dark the way Jupiter is for us. We're permanently stuck near the Sun, and the only question is how far from it we're allowed to drift. That angle has a maximum. It shrinks the further out you go, and it's the whole story. Everything that follows is that one number getting smaller. From Mars, the number is 41 degrees, and 41 degrees is a generous gap, roughly your outstretched hand laid across the sky 4 times. So Earth is still comfortably clear of the glare out there and gets to behave like a proper evening star. Curiosity photographed it about 80 minutes after sunset, from 160 million kilometres away, and Earth came out brighter than any actual star in that sky, with the Moon sitting just below as a second fainter point beside it. NASA's own note on that image says a person standing there with ordinary eyesight would see the two of them separately. No telescope, no help, just looking up after dark. And that is the last place in the solar system where any of that is true. Push out to Jupiter and 41 degrees collapses to 11. Earth is still bright, still that same blue-white, but it's now pinned so close to the Sun that it only ever clears the horizon a little before sunrise or a little after sunset, in a sky that's already going pale. Nobody has taken that photograph, and it isn't an oversight. It's that aiming a camera that near the Sun is roughly how you stop having a camera. By Saturn, it's 6 degrees, which is about 12 full moons laid edge to edge, and at that separation, the problem stops being brightness and starts being damage. So when Cassini went to take the picture, it waited. It waited until Saturn itself came between the spacecraft and the Sun, and then, sitting inside the shadow of a planet, with the sunlight physically blocked by something the size of Saturn, it turned around and took 323 images in a little over 4 hours. That's the photograph people know. The rings lit from behind and one small pale dot underneath them. And the light had to be blocked by an entire planet before that dot was safe to look at. Uranus takes it to 3 degrees, Neptune to under 2, and somewhere in there, Earth stops being an object in anybody's sky and becomes a detail inside the glare, something you could only recover if you already knew the exact spot and had a way to hold the Sun out of the frame. No spacecraft has tried it from either one, and there isn't much of an argument for going. The furthest anyone has ever managed was Voyager, 6 billion kilometres out from the Sun, far enough that Earth landed on roughly a single pixel. A pale blue dot sitting inside a band of scattered sunlight the camera picked up because it was pointed almost straight into it. Voyager took 60 frames that day, and 34 minutes later the cameras were switched off to save power, and they were never switched back on. All of that is what happens going outward, and going inward the geometry simply reverses. From Venus and from Mercury, Earth is the outer planet, which means it isn't tied to the Sun at all. It can swing right around to the opposite side of the sky and sit there at midnight. fully lit, the way Jupiter and Saturn do for us. The best view of Earth in the solar system is from the two planets nearest the Sun, which is exactly backwards from how anyone would guess it. And it's also the one seat nobody is ever going to sit in. If the ladder going outward is the interesting one, the same walk works for the Sun, and the Sun changes far more dramatically than we do, so that's the one to watch next.